Hello bachcho, let's read the question. So the question says the radionuclide 56 Mn has a half-life of 2.58 hours and it is produced in a cyclotron by bombarding a manganese target with deuterons. The targets contain only the stable manganese isotope 55 Mn and the manganese deuteron reaction that produces 56 Mn is 55 Mn plus deuteron gives 56 Mn plus proton. If the bombardment lasts much longer than the half-life of 56 Mn, the activity of 56 Mn produced in the target reaches a final value of 8.88 into 10 to the power 10 BQ. At what rate is 56 Mn being produced? So part A asks the rate of production of 56 Mn. Part B asks us how many 56 Mn nuclei are then in the target, and C asks what is their total mass. So let us first revise the key concept behind this question. So what is the key concept behind this question? It is concept of half-life. So half-life is the time period after which the content of the radioactive material becomes half of its original amount. It is denoted by T half and is given by the formula natural log of 2 over lambda. Here lambda is decay constant. Okay. And the second key concept is activity. So activity is the rate of decay of the number of rate of decay of the radioactive material. So it is denoted by A and is given by A is equal to lambda times N, where N is the number of undecayed nuclei at that time. So these are two concepts we need to remember. And let's check our solution. So for solution part, question A, it asks us at what rate is Mn56 being produced. So Mn56 is being produced by this reaction. So we can write here the rate at which 56 Mn is being produced after the reaction reaches a constant value of 8.88 into 10 to the power 10 BQ. So here activity will be equal to rate of production. Why? Because at equilibrium, when the activity comes here, it becomes constant. Hence, at the equilibrium, the rate of production will be equal to rate of disintegration, which is also known as activity. So, rate of production will be given by activity, which is equal to 8.88 into 10 to the power 10 BQ. Okay, so it will be equal to this. Now, in the second part, what is being asked? How many 56 Mn nuclei are then in the target? So it can again be said that activity for option part B, we have activity is equal to lambda n, and it will be equal to rate of production, okay, which will be equal to 8.88 into 10 to the power 10 BQ. Okay, let's get rid of the unit, and from here we can write the value of lambda is equal to natural log of 2. Lambda is equal to natural log of 2 over T half. So let's put it back in this previous equation. We have ln 2 over T half into N is equal to 8.88 into 10 to the power 10. So from here we have T half we have been given as 2.58 hours. So here N will be equal to 8.88 into 10 to the power 10 upon 0.693, which is the value of ln 2, into T half, which is 2.58 into we have to convert hours into seconds, so it will be 3600. So after solving this, we get 19015.065 into 10 to the power 10. So converting it into scientific notation, we get 1.19 into 10 to the power 15. So this will be the value of n at that time. Now the final thing we need to answer is what is their total mass. So for mass we have to do nothing but multiply the number of n into their mass, which is given as 56. So into 56, so it will be equal to 1.19 into 10 to the power 15 into 56. So it will be equal to 66.64 into 10 to the power 15, or is equal to 6.664 into 10 to the power 16. So this this times AMU. So this will be the mass. So all the three answers are here with us. Let's highlight them. So this is answer for part C. This is answer for part B, and this is the answer for part A. I hope you understood it well. Thank you.